So this is problem 3 from the homework set with the forces on ramps. So in this problem we have a ramp and it has a 64.5 kilogram block on the ramp. The angle of the incline here is 14.5 degrees. And what it says is we push with an additional force going down the ramp of 100 newtons. And the block still doesn't move. So that means friction is actually keeping the block in static equilibrium still. So that means that F net is 0 newtons since we're in static equilibrium, which means that the force going up the ramp has to be equal in magnitude to the force going down the ramp. So if we look at the total forces going up the ramp, the only one going up the ramp is the force due to friction. So friction is the only one that's going to act in that direction going up the ramp, resisting the motion of the object. The total forces going down the ramp are going to be our applied force, the force that we're pushing on it with, force applied, and the force of the weight going down the ramp, which we've done before as F down. So to find the force of friction in this problem, all we really need to do, since we're given the applied force of 100 newtons, is find F down, the way we would normally. So remember we have our weight going down, which in this case the weight is mg, or 64.5 kilograms plus times the 10 meters per second squared, which will be gravity. So we know we have a 645 newton weight for our object. F down, using our trig functions, we have F in here, the triangle part going into the ramp, the force of the weight going into the ramp, and F down being the part of the weight that's going down the ramp is going to be the weight times the sine of our angle. So we would do 645 times the sine of 14.5 degrees. And when you do that, you get that the force going down the ramp is 165 newtons. So for our F down, total F down, we have our applied force of 100 plus the part of the weight going down the ramp is 165. So that makes the total weight, or the total force going down the ramp, 265 newtons. So that means that the frictional force resisting the motion also has to be 200